Hello, this is Farhan Shakil from the Republic 2.0, and today we are going to discuss the physics Edexcel paper, and that is from January 25, right? So first of all, in the part one of this video, we are going to talk about the multiple choices of this paper, and here we're going to start from question number one. So question number one says that the stress is applied to a sample of material, and you have got a stress strain curve. Which of the following gives the Young's modulus of the material? So for example, whenever you want to calculate the gradient of this graph, the gradient of this graph would give you stress upon strain, which is also a basic formula for the Young's modulus, right? So you have to keep it like Young's modulus. So what does that mean? That the gradient of this curve is going to give you the Young's modulus. So the B has to be the right answer. Now, similarly, if you talk about question number two, a coin and a feather are dropped from the same height through air. Which row of the table is correct as the coin and feather fall to the ground? So as the coin and feather are falling to the ground, what does that mean? That they should be having the same initial acceleration because they are both falling under constant acceleration due to gravity. But since we both know that the coin having a higher mass would be feeling less resistance. And if it is feeling less resistance, less air resistance, the coin would be taking less time to reach the ground. So that is why we have to go with the option number C. Similarly, the third one, it is a very simple thing. It's just asking you about the vector or scalar quantities. So everybody knows that acceleration is a vector and work done is a scalar quantity. So that is why you just need to go with C. And now, if you're talking about this question number 4, a spring is stretched beyond its elastic limit. So everybody knows that whenever something is stretched beyond its elastic limit, what does that mean? That the body or the spring is not going to get back to its original shape. So which of the following describes the behavior of the spring? So what does that mean? That, the extension of the string always proportional to the force applied? No, it doesn't apply right after the elastic limit. Plastic deformation occurs until the spring reaches its elastic limit. Not really. It is just the elastic deformation until the elastic limit. The spring only shows elastic deformation. No, since it is being stretched beyond the elastic limit, so it is also showing plastic deformation. And the D1, the string does not return to its original length. So that is true. And that is why you just need to go with D. Now, similarly, if you're talking about this question number 5, they have given you an acceleration time graph and the body is deaccelerating. And if you want to calculate the area under the graph, what that is going to give you, this is a simple rhombus shape. So even if you want to calculate the area under this graph, it just need to be something like A times T. Or if you just need to you know, apply the simple formula, it must be 1 by 2 A1 plus A2 times of T. So it is the average acceleration times t, which everybody knows that is equal to the change in velocity. So what does that mean? That the body has undergone some change in the velocity. So that is why we can just simply select the option number D as the final answer. Now, question number 6. When a force is applied to a spring of stiffness K, the extension of the spring is delta x. What does that mean? That delta x has to be, since everybody knows that F is equals to K delta X, the magnitude of the elastic force is F is equals to K delta X. So delta X is going to be F upon K. Now we've got a new expression for the extension, delta X hash. The force is being doubled, so it would be 2F, and the stiffness of the spring has been made 3 times K. So after this transformation, you can also simply write a delta X hash equals to 2 by 3 times F upon K. So 2 by 3 times delta X. So delta X hash would eventually be 2 by 3 times delta X. So that is why after these transformations, the extension becomes 2 by 3 times of delta X. Now, a student drops a ball and measures the time taken for the ball to reach the ground. He repeats this for different heights. He uses a graphical method to determine a value of g, the acceleration of the free fall. He plots height on the y-axis. For example, you got height on the y-axis Which row of the table is correct for the student's graph? Well, that is a very famous practical. Whenever you're going to plot S over here and T square over here, and you're going to calculate the gradient of this graph. So we do know that S is equal to 1 by 2 GT square. So if you want to calculate the gradient of this graph, that is going to give you S upon T square equals to G upon 2. So if we plot if we plot the square of time on x-axis, we would be having a gradient of the graph which is equals to G by 2. So what does that mean? That C has to be the right answer. Now, the velocity time graph is given, and which of the following gives the distance traveled by the train in the time t. So you can just split this shape up. So you've got this one triangle and then this one rectangle. So the area of this triangle has to be 1 by 2 times t times v, plus we've got a rectangle down there, and that is going to be v times 2t. So we would just be having vt divided by 2 plus 2vt, and upon addition, it is going to give us 5vt divided by 2. So I'm just going to look for that option, and here we go. We have got this one, D, right? Right after this question, we have got this question number 9. And in question number 9, we have been given that we've got an upthrust of 90 Newton, we've got a weight of 49 Newton, and then there is a drag, and the body is accelerating upwards 5 times 4. So the force acting upwards has to be something like 5 times 4. So if you want to calculate the drag force would just simply be, if you want to calculate the drag force has to be, if the body is not moving or the resultant force is 0, the drag force would just simply be weight minus the upthrust. But if the body is accelerating upwards, you need to subtract that upward force as well. So drag force must be equal to weight minus upthrust minus the force, the upward acting force. The weight is 90, the upthrust is 49, and the force acting upwards is simply, F is equals to ma, you have got m, you have got a, so 5 times 4. So that is how you can easily calculate the drag force. And it has to be this one, C. So that is why you have to go with option number C. And now, if you look at this question number 10, we've got the traffic lights of the weight are suspended from a wire. The wire is held at an angle theta to the horizontal by the two supports as shown in the figure. Which of the following expression gives the tension in the wire? So how would you calculate the tension in the wire? Well, if you really want to calculate tension in the wire, the weight of this traffic light must be equal to, since we've got two T's over here, we've got two strings which are plugging up the traffic lights. So it must be 2t sine theta. We are always going to take the vertical component because it is only the vertical component that is going to give us the reaction of the weight, because the weight acts vertically downwards. So tension must also be acting vertically. So if you want to calculate tensions from here, it has to be W upon 2 sine theta. So that is why you have to go with the option number B. Is that clear? So, in the part 1 of this video, we'll be talking about the multiple choices. So we'll be back with the part 2 only to discuss the later part of this paper. Thank you very much.